Global temperatures are rising due to climate change, but in the Arctic they are rising at 3 times the average rate due to positive feedback loop effects. The impact of these increasing temperatures is becoming progressively more noticeable, with sea ice declining at a rate of 13% each year, and some studies predicting that by 2050 there will be no sea ice cover in the Arctic during the summer months. Sea ice cover is beneficial for ecosystem stability and climate regulation. One way that sea ice helps regulate temperature is through the ice albedo effect. Ice reflects between 50 to 70% of incoming solar radiation, which helps to reduce the surface temperature. The ocean on the other hand only reflects around 6% of incoming radiation and absorbs the rest, meaning less ice coverage accelerates surface temperature rise. As well as reflecting incoming solar radiation, sea ice acts as a physical boundary between the atmosphere and the sea, which reduces the rate of ocean acidification due to atmospheric carbon uptake. As atmospheric CO2 concentration increases, more is dissolved into the ocean and reacts with water and free carbonate ions to form carbonic acid, reducing its pH and leading to oversaturation. The Arctic is already naturally vulnerable to ocean acidification due to the fact that CO2 is more water-soluble at lower temperatures, so the added impact of losing sea ice means there is greater liquid-gas exchange. One of the most concerning impacts of melting ice in the Arctic is its potential to disrupt the natural thermohaline circulation of the oceans. In normal climatic conditions the formation of freshwater ice in the Arctic expels salt into the surrounding water, forming extremely dense and cold water. This water sinks to the bottom and collides with other bodies of deep water, causing it to eventually upwell nutrient-rich cold water in other parts of the world. The water at the surface then warms and makes its way back to the poles, where the cycle begins again. This slow mixing of layers of water has many benefits, such as moving carbon away from the surface, transporting nutrients across the globe and regulating temperature. However, as ice begins to melt and release fresh water, the density of the water at the surface of the poles decreases and is less able to sink. The more ice that melts, the more profound this disruption becomes, and may eventually lead to there being no mixing of the stratified layers at all.
So, now we've learned about what climate change is and how it affects the ocean, let's learn about how it affects the ecosystem of the Arctic. The Arctic ecosystem has a complicated food web involving everything from seals and walrus to zooplankton and jellyfish. Climate change creates many problems in the ecosystem, from vanishing habitats to declines and extinctions to changes in species interactions. The temperature change is causing a rapid loss of many Arctic habitats, the most noticeable being glaciers and sea ice. This then causes a knock-on effect leading to the destruction of other habitats. An example of this would be the melting of permafrost, which can lead to the drainage of tundra wetlands, which then causes more water to flow to the coast, which in turn then increases erosion, nutrient runoff, and pollution. This can then boost ocean acidification, making many areas harder to live in for calcifying creatures. This can then snowball into creating larger knock-on effects for the environment. These knock-on effects can cause many other problems. Looking at just the reduced sea ice cover, we can see that these previously covered ice areas become more accessible for human activities. This then increases the number of shipping, fishing, and tourism vessels in the area. This then, of course, creates more problems from overfishing to increased pollution. These warming conditions also create changes in species behavior. The increased temperature causes the advancement of spring conditions, which has led to many species advancing the timing of critical activities, such as egg laying or flowering. The problem with this is that most species do not advance their timing in sync with every other species. This then causes disruptions in important interspecies relationships. Another big change that this causes is the altering of host-pathogen relationships. Often, this higher temperature is a more suitable breeding ground for these pathogens, causing diseases to multiply much faster. This also increases the pathogen transmission rate, although this is not helped by the changes in movement patterns caused by the lack of sea ice cover. An example of this would be the 2018 unusual pinniped mortality event, which was on the northeast coast of the USA. Many investigated pinnipeds had a pathogen known as phocine distemper virus, with many living seals starting to show symptoms which include sneezing, coughing, discharge from the eyes, and seizures. If we continue to look at pinnipeds, we can see that this is not the only issue that they are facing. Ringed seals are a species that give birth and nurse their young on sea ice. They construct snow layers for protection from predators as well as from the heat. These layers can be destroyed by an early snowmelt. This then subjects the pup to adverse weather conditions earlier than expected, causing the life expectancy of the pup to decrease. This is important because many seals have evolved their life history traits around the ice. For example, harp seals use this ice as part of their truncated nursing method. After about 12 days, the mother abruptly stops feeding the pup. The ice then protects the pup until they get hungry enough to start to venture out to feed for themselves. If this ice collapsed early, then this pup would likely die. Ringed seals, along with many other species, use ice as a resting ground. The increased temperature has decreased the amount of sea ice. This has often meant that there is either no space for seals to rest on, or the sea ice is very crowded, causing the seals to become restless. These bunched up seals are also easier prey for predators such as killer whales or polar bears.
Although seals are becoming more vulnerable to predation due to changes in the Arctic, the predators themselves are also facing major threats to their survival. A notable example is the flagship species of Arctic decline, the polar bear. As apex predators in the Arctic that evolved to flourish on a rich diet of blubber, the repercussions of seal population decline directly influences the nutritional quality of their diet. However, even if seal populations were thriving, sea ice constitutes over 96% of a polar bear's critical habitat, and the rate it is melting is having notable effects on the fitness and size of the population. Polar bears are dependent on sea ice in the winter to access their preferred prey, as it allows them to wait and hunt around the gaps in the ice seals use to breathe and access their dens. With less ice coverage year-round, they have a reduced hunting area and fewer months to hunt in, leading to higher rates of starvation and lower reproductive success. During the transition season into and away from the winter months, the thinner ice they hunt on is more prone to breaking and leaving them stranded. Whilst they are strong swimmers and can normally return to the ice, this requires more energy for them, so is a less efficient hunting method and a drain on their reserves. This is especially deadly for already malnourished polar bears and can lead to drowning. During the summer months, polar bears are forced inland due to ice loss, and their diet subsequently changes. One study released in 2022 by Rode et al. Studied the isotope composition of polar bear hairs to compare their diet to population survival. They found that groups of polar bears surviving on higher protein, less energy-dense prey such as walruses and whale carcasses were more likely to experience population decline. On land, they are also more likely to come into contact with humans and their waste, which is increasingly leading to conflicts as the bears scavenge for food. Large groups of polar bears have been noticed all over the Arctic Circle invading anthropogenic waste sites, and in some instances attempting to access buildings. As indiscriminate foragers, the bears consume any waste they find with traces of food, including packaging, batteries and wood. This has caused serious health problems in some bears, and leads to premature death. With so many changes occurring in the Arctic as the Earth warms, it's almost impossible to know the full extent that the ecosystem is being affected both now and in the future. Whilst we discussed just a handful of mammals, everything from the smallest phytoplankton to the largest whale will be forced to adapt as the world becomes warmer and more polluted.